The number of roots of a quadratic. Well, roots, remember, are where they cross the x-axis. They're x-intercepts. So this one never crosses it, so it has 0. This one also never crosses it, so it has 0. This one crosses once. It happens to be the vertex if a parabolic function, a quadratic function, crosses the x-axis once, it will be the vertex. So, what we can do to figure out quickly how many roots there are is to take the discriminant. You could find the roots, but this is part of the quadratic formula. If you remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's the b squared minus 4ac underneath the radical. If that's positive, then we'll have plus or minus 2 solutions. If it's less than 0, then we can't take the square root of a negative, so there is 0 solution. If we have this being 0, square root of 0 is 0, but adding 0 and subtracting 0 are the same thing. That's one solution, which is the vertex. You'll also notice this negative b over 2a we also use to find axis of symmetry, or the x-coordinate of the vertex. So, if you plug in the values for b squared minus 4ac, you will figure out how many solutions there are. The number won't be how many solutions. You have to compare it to 0. So, the discriminant, b squared minus 4ac, is, b is negative 2, squared minus 4 times 6 times negative 3. 4 plus 24 times 3 is 72, which is positive. So there are 2 solutions. The next one, we have b is negative 1, a is negative 2, c is negative 1. So we have 1 minus 8, which is negative 7. That's negative, so 0 solutions. A is negative 4, b is negative 4, c is 5. So negative 4 squared minus 4 times negative 4 times 5 is 16 minus 16 times 5 is 80. Negative times negative is a positive. So 96, that's positive, so 2 solutions. You can probably guess how many solutions this last one will be if you've been following the pattern. Just in case, I'll do it out. So b squared minus 4ac. B is 8. A is 16. C is 1, so this is 64. Minus 64 gives us 0, which means there's 1 solution. This is faster than finding the roots. If you also have to find the roots, just find the roots. But this is a fast way to determine the number of roots of a quadratic. Or you could just graph it.